Good morning, guys. Today we're going to look at SPI 5.8. That's independent and conditional probabilities. Probability, you know, is number of successes over number of possible outcomes. So when we talk about independent, that's where we have a lot of things going on, but they don't affect each other. And then conditional probabilities is where we have a lot of different events going on, but we want to look at one specific event out of all of those, or one specific condition. So let's look at the first example. Sam was asked 3 multiple choice questions on a quiz. Each question had 4 answer options, of which only 1 was correct. If Sam randomly chose an option for each question, what's the probability that he chose the correct option on all 3 questions? So we can see there's multiple events going on. He's making multiple guesses. But these are independent, because independent is when you have multiple events whose outcomes do not affect the outcomes of the other events. Whatever he guessed for the first choice doesn't matter or doesn't affect his chance of getting the second guess right, or the third guess right doesn't affect the chance of getting the first guess right. Each question is works independently of the other one. So that tells me it's an independent probability. Now we want to know the probability that he chooses the correct option on all 3 questions. That's the multiple events. Now when we have multiple events like this, it's probability of A and B, both of them happening. Then we just do first one times the second one. Probability of A times probability of B. So we just break it off and do individual problems, multiply them together. So in this case, probability that he gets all 3 guesses correct, well, let's look at them as the individual groups. Probability of getting the first guess correct, and the probability of getting the second guess correct, and the third guess correct. So this is what we're trying to find. We're just breaking down the probability that he chose the correct option on all 3 questions. We just rewriting that to say first guess is correct, and second guess is correct, and third guess is correct. Because as soon as I see it with those ands, I should remember to multiply that. And that should be on my reference page at the bottom of the last page. Right here, independent, probability of A and B is probability of A times probability of B. So there's the little reminder right there that I multiply when I've got multiple events that don't affect each other. So we just continue to break it up. Probability of first guess correct. So let's work it out. Well, we know probability is number of successful outcomes over number of possible outcomes. Well, there's 4 choices and only 1 of them can be correct. So 1 out of 4 chance of getting it correct if he guesses. So first question had a 1 in 4 chance of getting it right. Second question had a 1 in 4 chance of getting it right. Third had a 1 in 4 chance of getting it right. Operation is multiply each of them. 1/4 times 1/4 times 1/4 is 1 over 64, choice A. So we just need to recognize that when we see probability, that we need to identify if it's an independent probability, they don't affect each other, or if it's some other type of probability, like the binomial probabilities we've looked at in other SPIs, or the conditional probability we're going to look at in the next example. So let's look at that next example. The table below shows the percent of teenagers who own skateboards and roller skates in a particular town. So multiple events, multiple age groups, skateboard owners, roller skate owners, and we're just going to look at the probability of getting one group versus the other. If a randomly selected teenager is in the 16 to 18 age group, what's the probability that the teenager owns a skateboard? Well, this is a conditional probability because there are multiple events, but a condition has been put on what group the probability is based on. They only want us to look at the 16 to 18-year-olds. They said if a randomly selected teenager is in the 16 to 18 age group. So only looking at this 16 to 18 age group allows us to calculate it as a single event probability. And we're only going to look at the group that the condition states. So we're not going to have to look at these 13 to 15-year-olds and these roller skates. We're not going to look at all this other mess. Only the 16 to 18-year-olds matter. 13 and 15-year-olds, they're gone because we don't care about them. That condition was put on there. Ignore them. Just look at the 16 to 18-year-olds. Now we want the probability that they own a skateboard. So there's my success. Success out of possible, or probability of a teenager owns a skateboard if the teenager is in the 16 to 18 age group. Well, it tells me right here, 16% of the teenagers, 16% of the 16 to 18-year-olds own skateboards. That's success. And possible is all the 16 to 18-year-olds. So 16% plus 28% gives us all the 16 to 18-year-olds. So my skateboard owners for 16 to 18 18-year-old over all 16 to 18-year-olds. So 0.16, that's 16%, plus 0.16 plus 0.28 gives us 6.16 over 0.44. Calculator tells me it's 0.36363636. Math fraction tells me that's 4 over 11. If I forget how to do math fraction, I can key each of these choices in until I get 4 over 11. So as you can see, they put this condition on there, and just a hint, it's usually when they give you information like in a table like this. But they'll put a condition on a probability problem, and that tells you just look at that one group, and that's going to be your success is going to be whatever they specify, and your possible is going to be that whole group added together. And then you just do your simple probability success over possible. So there's independent events, like in the last example, multiply them all together. And then there's conditional probability, where we only have to look at the one group that the condition tells us to look at. That's SPI 5.8, and I will see you in class tomorrow, guys.